Hello, Algebra 2, Part 2. This is Parabolas Day 1. So we're going to be talking about whether or not a parabola opens up or down, finding the vertex, finding the max or min value, identifying the domain, range, and the axis of symmetry. And this might seem like a lot, but actually most of this is related to just finding the vertex of the parabola. So if we find the vertex, we can pretty much get the answers to all the other pieces. So first we want to go over a few basics of a parabola. A parabola is the graph of a quadratic function. So reminder, a quadratic function is ax squared plus bx plus c equals 0. And so you had a lot of practice factoring and foiling these in chapter 5, and then in the beginning of chapter 8 you had a lot of practice solving these. So what a parabola looks like, it's kind of this curved or U shape, and it has a vertex, it has a y-intercept, and sometimes it has x-intercepts, and it can have 0, 1, or 2 x-intercepts. And so when we get to that lesson, we'll talk about why it would have 0, 1, or 2 x-intercepts. And then it has this line, the axis of symmetry, and what that says is that you can fold the parabola in half across that axis of symmetry, and it's going to be a perfect reflection of itself on either side. And so we can have parabolas that open up, and we can have parabolas that open down. And so what we're going to do in this lesson is figure out how to identify some properties of these parabolas from their algebraic functions. So first thing, does it open up or down? So to do that, you're going to look at the a term from your ax squared plus bx plus c. And if your a is positive, then the parabola opens up. And if the a is negative, then it opens down. Now, finding the vertex, so we've got some formulas that we can use to find the vertex, and there are actually two ways that you can do this. So the first way, if your parabola looks like a quadratic equation in standard form, ax squared plus bx plus c equals 0, you can use this formula, negative b over 2a. And so that formula, negative b over 2a, so I would just pull my b and a from the quadratic equation that we're given, and if we plug them into that, that's going to give us the x-coordinate of it. And then what you would do is you would take your x-coordinate and plug it into the equation, and that will give you your y-coordinate, okay? So we almost always have to find our x-coordinate first, and then we find our x-coordinate, plug that in, and then that gives us our y-coordinate. The other way that we could find our vertex is if the equation looks like this. Y equals a times x minus h squared plus k. And this is really easy. When you see this, you might think, well, gee, I have to take that x minus h squared, expand that out, distribute the a, add the k, simplify everything, and then run through negative b over 2a and get... you could do that if you want to. It would take you a lot of time. But this is actually a very special form of the quadratic function. This is called vertex form. And the reason why it's called vertex form is because we can find the vertex by just looking at it. And so typically we call the x-coordinate of our vertex the h. And so the h is going to be the number that is added or subtracted to your x inside the parentheses there. And then typically our k is our y-coordinate, and that's going to be the number that's added on the same side, the number that's added or subtracted on the same side as the equal sign as your x. Now, one thing to say about that, if you notice, in the formula that's given here, we have a minus h, but then when we go to our parentheses here, it's a positive h. Okay, so when you use vertex form, my one disclaimer on this is you have to flip the sign of h to get your x-coordinate. And we'll run through some practices of that. Okay, so how can I tell if a parabola has a min or a max value? Well, that all depends on its a term and whether or not it opens up or down. So it's going to have a max value if it opens down and it has a negative a term. And that makes sense because if our parabola opens down, it looks like that, right? So it's only going to have a high point or a max. And then if a parabola opens up, it'll have a minimum value, right? and that has a positive a term, right? So if it opens up, it looks like a right side up u, okay, and then it has a low point, and so in that case it has a minimum value. And the max or the min value is going to be the same as the y-coordinate of the vertex. So you don't have to do any extra work. If you've already found your vertex, then you can just pull your y-coordinate out, and that's going to be your max or min value. And what is the domain of a parabola? The domain of a parabola is very easy. It's all real numbers. And the reason for that is because you can plug in any value of x into a quadratic equation and it'll work out just fine. Okay, so all real numbers, that'll be your answer for that question all day long. And so then what about the range though? Well, there are some restrictions on the range of a parabola, and we can find these really easily. And again, this is something else that's going to depend on whether or not the parabola has a positive or negative a, and whether or not it opens up or down. So if it has a positive a and it opens up, and then it has only a min value, then the range is going to be this. You'll have a bracket sign, and then you'll plug in the y-coordinate of your vertex, and then that'll go to infinity, and then you'll close it off with the parentheses. If it has a negative a, it opens down. It only has a max value, and then in that case, you'll use your range will start at negative infinity, and then you'll plug in your y-coordinate of x, and then you'll close it off with a bracket. Okay, so you just kind of flip-flop the order and which infinity you use, whether it's positive infinity or negative infinity. And so how do we find the axis of symmetry? Well, if you've already found your vertex, that's really easy. The axis of symmetry is just the exact same thing as the x-coordinate of your vertex, okay? So negative b over 2a. So for our classwork, we have a few parabolas here, and we're going to find the following pieces of information from each one. So for number 1, we have y equals x squared plus 10x plus 25, and we want to figure out, well, does it open up or down? Well, my a value is a positive 1, so this is going to open up, okay? So finding our vertex, so we'll start off by finding the x-coordinate of the vertex, which is going to be negative b over 2a. So that's going to be a negative 10 over 2 times 1. So negative 10 over 2, which is negative 5. Okay? And then we'll plug that in to find the y of the vertex. So then y is going to be negative 5 squared plus 10 times negative 5 plus 25. So that'll be 25 minus 50 plus 25. So let's see. That's going to simplify to 0. Okay? So the x of our vertex is negative 5. The y is 0. So then we say our vertex is negative 5, 0. Now the max or min value, well, does it open up or down? So remember we said if the parabola opens up, right, it looks like that. So it's going to have a min value, and that min value is the same as the y of our vertex, which is going to be 0. The domain for every parabola is all real numbers. And then the range, well, it depends on whether or not we open up or down. So for this one, we open up. So our range is going to start at our min value, which is negative 5. So we'll have a bracket, negative 5, and then it'll go up to positive infinity. Okay, and then the axis of symmetry, that's the same as the x-coordinate of our vertex, and we can say that's just x equals negative 5. So you see, the hard part was finding the vertex, and then from there, we just go ahead and we can use that to pull out all these other pieces of information. And so the other thing that you had to do was draw a very rough sketch. Well, the kind of sketch that I want you to do is just whether it opens up or down, and then go ahead and label your vertex, which is going to be -5, 0. So that's good enough for our sketches for what we're doing and how far we've gotten into the whole subject of parabolas for now. Okay, so let's see, let's go on to number 2. So number 2 looks a little different. So we're going to have to FOIL that one out to get some answers here. So let's see. If I multiply my first, I'll get 2x squared. If I multiply my outers, I'll get -3x. And then if I multiply my inners, I'll get plus 8x. And then if I multiply my last, I'll get -12. Okay, and so we can go ahead and simplify that. So I've got 2x squared plus 5x minus 12. And so now I can use this and I can see, well, my a term is a +2, so that means it's going to open up, and we can find our vertex. So the x of our vertex is going to be -b over 2a, so that'll be -5 over 2 times 2, which is going to be -5 over 4. Okay, so the x-coordinate of our vertex is -5 over 4, and then we'll plug that in to find the y-coordinate. Now, this is something that we would end up graphing, and so in this case, because we've got a fraction, it would be easiest just to turn this into a decimal and get a decimal for our y-coordinate. So we're going to go ahead and say that this is going to be, let's see, -5 over 4, I think that's -1.25, yeah. So this is -1.25, and then we'll go ahead and plug that in. So we'll have 2 times -1.25 squared plus 5 times -1.25 minus 12. Okay, so -1.25 squared times 2 plus 5 times -1.25 minus 12. And so we're going to get -21.375. So then we can say our vertex is going to be -1.25, comma, -21.375. And so we said that this is going to be opening up. So it would look like this. And so you can see if it's opening up, we have a low point. So we'll have a min value, which is the same as the y-coordinate of our vertex, which is -21.375. The domain is all real numbers, and your range, well, if it has a minimum, that means it's going to start at -21.375, and then that'll go up to positive infinity. And the axis of symmetry is the same as the x-coordinate of the vertex, which is -1.25. Okay, and then we just have to do a rough sketch. So we open up, and then we'll label our vertex, which is going to be -1.25, comma, -21.375. And so that's it for number 2. So we'll go on to number 3. Now number 3 is in vertex form. So this one should be easy to find our vertex. But first off, we want to identify if it opens up or down. And the a term is hidden. It's that imaginary one, or that one that you can't see that's hiding in front of the parentheses. So you can see that's a positive one there. So this is going to open up. And so your vertex, well, your vertex we can just pull right out of this. So the x-coordinate of our vertex is actually going to be a positive one, because remember, when it's in vertex form, you have to flip the sign on your x-coordinate. Your y will stay the same, and the y-coordinate of your vertex is a +5, okay? So our answer for our vertex is going to be +1, +5. So our max or min value, well, if we open up, we have a min value, and that's going to be the y of our vertex, which is 5. Our domain is all real numbers. And then our range, so that is going to start at our min value of 5 and go up to infinity. And then your axis of symmetry is the same as the x-coordinate of our vertex, which is 1. Okay, so number 3 was nice and easy because it was in vertex form. So going on to number 4, so this is also in vertex form, so this should also be easy. So does it open up or down? Well, we can see our a value here is a positive 3, so that means it's going to open up. And then our vertex, okay, so remember to get your x coordinate, we have to flip the sign, so that'll be a -1. And then we keep the same sign of our y coordinate, which is going to be a -3. So the vertex is going to be -1, -3. And does it have a max or min value? Well, if it opens up, it's going to have a min value, and that's our y coordinate, which is -3. And so we can actually label our vertex right here. -1, -3. Oh, and did I forget to label our vertex in the previous sketch? I did. Okay, so we can label our vertex here, 1, 5. All right, so going back to this one. So we've got a vertex of -1, -3, a min value of -3. Our domain is all real numbers. And then our range, well, if we have a min of -3, that means my range is going to start at -3 and go up to positive infinity. And then the axis of symmetry is the same as the x-coordinate of my vertex, which is just -1. So that's it for number 4. So going on to number 5. Okay, so this one doesn't have a B term or a C term. So for that case, you can think about those as being 0. And so that'll kind of affect a little bit what we do with our formulas. Now, notice that our A term is a -1/4. Okay, so we've got our first negative value. So this one is going to open down. And so to find our vertex, well, the x-coordinate of our vertex is going to be -b over 2a. And so my b term is 0, okay? And then, let's see, a is -1/4. Well, it doesn't really matter what a is because b is 0. So the x-coordinate of my vertex is just 0. And then to find the y-coordinate, well, we would just plug that x-coordinate in. And again, we get 0. So our vertex is 0, 0. So a max or a min value, well, this opens down. So we'll have a max value, right? And our vertex is there at 0, 0. So our max value is the y-coordinate of our vertex, which is 0. The domain is all real numbers. And then your range is going to, start. So because this one opens down, our range is going to be different than all the other ones we did. So it'll start at -infinity, and then it'll go up to our max value of 0 and end there. And then our axis of symmetry is the same as the x of our vertex, which is 0. All right, and the last problem, number 6. So number 6 is in vertex form, but we don't have a k value, right? Normally, we would have a plus k here, but there's nothing there. So then what that's going to mean, is our k value is 0. And so the y of our vertex is 0, okay? And then remember, we get the x of our vertex from flipping the sign from inside the parentheses. So the x of our vertex is going to be a positive 2. Okay, so your vertex is going to be 2, 0. And so does this open up or down? Well, you've got this positive 1 hiding in front of your parentheses that we just can't see. So we're going to say this opens up, right? So we've got a parabola that opens up, and our vertex is down here at 2, 0. So a max or a min value, we're going to have a min. Min is always the same as your y-coordinate, which is going to be 0. The domain is all real numbers. And then the range, well, we'll start at our min of 0, and we'll go up to positive infinity, and then the axis of symmetry is the same as our x-coordinate of our vertex, which is just 2. So that's it for the classwork. So hopefully from that you can go ahead and figure out the homework and submit that.